Welcome back to Applied Mathematics. In this video, we're going to be multiplying by a monomial. We've talked about the vocabulary of monomials and polynomials in the past, but it's been a while, so a brief refresher, if I get my head out of the way. A monomial is the product of a constant and one or more variables. So a constant by itself does count as a monomial. A constant times a variable counts as a monomial. A constant times a variable times a different variable counts as a monomial. And if you have powers on those variables, it still counts, because x cubed is just multiplying by x 3 times. Finally, if you leave the constant off, it still counts, because of course you can always multiply something by 1 without changing it. A polynomial is the sum of several monomial terms. So something as simple as x plus 7, x cubed plus 3xy minus 9, so on and so on. And so if we are multiplying a couple of monomials, I can use the commutative and associative properties to rearrange. Right? 3x squared times 7x to the fifth is the same thing as 3 times 7 and then x squared times x to the fifth. 3 times 7 is just 21, nothing strange going on there. X to the 7th times x to the 5th, no, not 7th, 2nd. Sorry about that. X to the 2nd times x to the 5th is x to the 2 plus 5, and 2 plus 5 is 7. This works just as well when you have 3 terms, when you have several variables, whatever you might have. How about 9xy times 20y squared times 2z? Well, we have all of our constants, 9 times 20 times 2. We have our lone x term. We have y times y squared. And we have our lone z term. 9 times 20 times 2 is 360. Then we have x. We have y times y squared, which is y cubed. And we have z. All right, nothing too crazy going on there. In a sense, multiplying something more complicated by a monomial is also something we've done before. The number 7 by itself is a monomial. Multiply that by a polynomial, like 2x plus 5, and hopefully you remember using the distributive property to write this as 7 times 2x plus 7 times 5. 7 times 2x is 14x, 7 times 5 is 35, and that's all there is to it. If we start adding extra variables into things, so we have something like 4x squared times x cubed minus 9, it doesn't change anything. We will have 4x squared times x cubed minus 4x squared times 9. Just the same distributive property. It looks intimidating because there's so many more variables and there's powers going on, but it's the same rule. X squared times x cubed. Multiplying like bases, you add the exponents. So we'll get 4x to the 5th. Then 4x squared times 9. 4 times 9 is 36. And then we've got an x squared hanging out. If we want to add more variables, we can do that without any issues whatsoever. 7xy times 4x squared minus 5xy plus 9y squared minus 12z. Let's make that look like a z. That's a little better. Right? More terms, but we can still distribute. More variables, but we can still use the rules we already know. So we will have 7xy times 4x squared minus 7xy times 5xy plus 7xy times 9y squared minus 7xy times 12z. Sorry, I'm running out of screen space. Right? 7 times 4 is 28. X times x squared is x cubed, and then there's a factor of y. 7 times 5 is 35. X times x is x squared. Y times y is y squared. 7 times 9 is 63. X, well, just one factor of x. Y times y squared is y cubed. And then 7 times 12 is 84. And then we have an x, a y, and a z. Because of the commutative and associative properties of addition and multiplication, you can scramble these things around. But we try to stick with an organization rule of thumb, right? In each term, put your variables in alphabetical order. X comes before Y, comes before Z. That just makes it a little bit easier to read, a little bit easier to look for like and unlike terms. Beyond that, we start looking at powers. And I tend to use descending order in this course. In some other courses, I use other rules. But notice we have an x cubed, we have an x squared, we have an x by itself, and we still have an x by itself. All right, so those first three make sense, and then you've got a couple of things with x in it. Well, I've got a y cubed and a y by itself. So y cubed comes first, y by itself comes later. We follow this rule of descending order variable by variable. There's no one right way to do it, but be consistent and it will help you in the long run. It helps you identify like terms. It helps you identify when there are things left to be done. For this video, that's all I have. So as always, thank you for joining me, and I'll see you next time.